Greetings, dear students. Welcome back to the world of current electricity. I hope you're enjoying this chapter. Now, dear students, in this module, we are trying to discuss some basic multiple choice question based on Wheatstone meter bridge. Now, since we have already discussed some numericals based on this, I have given you two hints to remember whenever you are solving the numericals as well as MCQs based on Wheatstone meter bridge. What are those two hints, dear students? Yes, first is when in balance condition, the equation comes out to be x upon r is equal to Lx upon 100 minus Lx. And what is Lx? Yes, that is the second point what we are going to remember, that Lx is nothing but the measurement of length from the left hand side. Yes, dear students. So keeping these concepts in mind, dear students, I will try to depict you to solve the first numerical, which is an MCQ based on meter bridge. The question is as follows. In a given arrangement of a meter bridge, okay, so the question itself is telling that the given circuit is of meter bridge. The null point is obtained at a distance x from the end. Okay, so can you see from the diagram that distance x is actually measured from the left hand side? Okay, now the hint is the null point is obtained. That means it is a condition of balancing. Yes, that means I can use the equation as x upon r is equal to Lx upon 100 minus Lx. The question further asked is, what will be the distance of null point from A if the radius of wire AB is doubled? Oh, the radius of the wire is doubled. But dear students, when we were deriving the equations for meter bridge, have we ever considered the radius of wire? I think I have not said you anything about it. That means, can I say the question solution is very, very simple. Why? Because we know that the change in diameter or the change in radius does not affect the ratio of the resistance. My formula will always be x upon r is equal to Lx upon 100 minus Lx. That means the concept is very, very simple, that the null point will be always at original position irrespective of the change in radius as well as diameter. Implies, dear students, that the distance will be x from the left position. Hence my correct answer is x. Easy it is? Yes. So moving ahead with our next question. In the circuit shown, a meter bridge is in balanced state. Oh, that means the given circuit is balanced. Again, can I say that the galvanometer will show null deflection? That means no current will pass through galvanometer. Implies that galvanometer is actually an open circuit. Yes. The meter bridge wire has a resistance of 0.1 ohm per centimeter. Okay. That means, can I say sigma is given to me resistance per length? Yes. What are the values of unknown resistance X and the current drawn from the battery of negligible resistance? That means I am supposed to find X, that is actually the resistance in the left gap of your meter bridge, right, dear students? As well as I am supposed to find the current. Now, if you closely see the option, dear students, you need to be very, very smart. Out of all the three options, the resistance are 4 ohms in 3 options. Implies that resistance has to be 4 ohms only. Anyways, we will try to find that, and if resistance comes out to be 4 ohms, that means my option A has to be incorrect, right? Okay, so let's move ahead. We know that for a balanced meter bridge, x upon r should be equal to Lx upon 100 minus Lx. What is x, dear students? X, that's what I'm supposed to find. What is r, dear students? Yes, r is given to me as 6 ohms. What is Lx? Lx is nothing but the length measured from the left hand side, that is comes out to be 40. And what is 100 minus Lx? Yes, 100 minus Lx has to be 60 centimeter. Perfect. So by this, I can find the value of x, which comes out to be 4 ohms. That's what I said you in start. Yes. So implies my option A is incorrect. Now, how do I find current? Finding current has only one and very 1 ohms law, right? So I is equal to V upon R. So I am supposed to find the potential as well as equivalent resistance. Can I not say that potential is given to me as 5 volts? right? So I'm only supposed to find the resistance, and I've already given you the hint in the start of this MCQ that since the current is not flowing through the galvanometer, my 4 ohms and 6 ohms are actually in series, which comes out to be 10 ohms, right? And if you see that 40 centimeter and below that, that is in 4 ohms. Why? Because sigma is given as R upon L. Yes, you know L, dear students, you can easily find R as well as you know sigma. So your 40 centimeter corresponds to 4 ohm and your 60 centimeter correspond to 6 ohm. But can I say again they are in series, so it will be again 10 ohms, and 10 ohms and 10 ohms are in parallel, dear students. So what should be your net or an equivalent resistance? Yes, we know the concept that 1 upon R parallel should be equal to 1 upon R1 plus 1 upon R2. Hence my equivalent resistance comes out to be 5 ohms. Now by Ohm's law, current can be written as the ratio of E upon R dash. What is E5? What is R? Yes, we got R to be 5. Hence the current flowing is 1 ampere. So my option C is correct. So my X is equal to 4 ohm and my current is 1 ampere. Thank you.